Welcome to Lecture 14, 2.1, a rectangular coordinate system and graphing utilities. So for first objective, we're going to plot points on a rectangular coordinate system. So this thing here is called the rectangular coordinate system, what you'd think of as a normal graph, also called a Cartesian coordinate plane, after the man who created it, René Descartes. I believe he was a Frenchman. Apparently the story is he was laying in bed and he was watching a fly crawl on the wall and was trying to discuss how he could describe to you where the fly was on the wall, and figured out if you were looking at the wall and this was a bunch of tiles, he could tell you. It was maybe, if this was your fly, for example, he would say, well, you go over 2 tiles or 3 tiles and then you go up 3 tiles and that's where the fly is. Apparently that's one of the stories I've heard for how René Descartes created this table. So let's go ahead and plot these values. So the value on here, these are the horizontal values, those are your x values. You've probably already seen plotting a table, but if you haven't, it's a good time for reviewing. And then these right here values, whole way along, are your y values, the vertical values. So right here we have our x values and our y values given, and they're given as pairs. So the first one we see is 0, 5, which you could also write as, this is point A, 0, 5. Well, that means for x, we don't move anywhere, we're stuck at 0, and then we go up to 5. So 0 and 1, 2, 3, 4, 5. So that is point A, and I'll label it point A. The next one, point B, is 5, 0. So this time, x is 5, so we'll go over 5, and then we don't move anywhere for y. And that's point B. Now point C. 6, 8. We move 6 for x, so 1, 2, 3, 4, 5, 6, and then we go up 8 to positive 8. 1, 2, 3, 4, 5, 6, 7, 8. So notice, where am I always starting when I plot points? I'm starting at this point here, which is called 0, 0, also called the origin. So always start there. Next point, D. For negative 9. Go ahead, try plot that one by yourself, as well as E and F, and check in with me in a second. Alright, so for D, we have 4, negative 9. So positive 4, 1, 2, 3, 4, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's D. Then E, negative 3, 7. So negative 3 for the x values, and then 7, so positive 7 for the y's. 1, 2, 3, 4, 5, 6, 7. And lastly, F. Negative 5, negative 5. So back for the x values, and then down for the y's. We have negative 5, negative 5. Alright, and there we go. Practiced graphing some points on Cartesian coordinate system, or also known as the rectangular coordinate system. Now, another thing to note is each of these are considered quadrants. So we have over here, let me go ahead and highlight it. This is quadrant 4, anything off to and beyond. That's quadrant 1, not quadrant 4. So this is quadrant 1. Then, oddly enough, we go counterclockwise when we're naming them. We have the next one, which is quadrant 2. Then quadrant 3 and quadrant 4. So the question is, what quadrant is point C in? So where is point C? Point C, right here, that is in quadrant 1. So our answer would be quadrant 1. Next question is, what quadrant is point F in? Well, where is F? F is right here, so that is in quadrant 3. Or you could write out 3 if you want. And the next point, or question, what quadrant is point A in? What do you think? Is that in quadrant 1 or quadrant 2? You know what? It's not in any quadrant. It is what we would call an intercept. It lies on one of these two axes. If a point lies on either in the green here, the x-axis, or on the yellow, which is the y-axis, those points are not actually in quadrants. They are intercepts, which are a special type of point, and we'll look at that in a little bit. So, what quadrant? It is not in a quadrant. It is an intercept. Sneaky question. Alright, objective 2. Use the distance and midpoint formulas. So the distance formula between 2 points, if we have x1, y1 as the first point, and x2, y2, x sub 2, y sub 2, as the second point, the distance formula is given by lowercase d equals the square root of the difference between the x's, then you square it, plus the difference between the y's, and then you square it. So that's the distance formula. Now the midpoint formula. The midpoint, it's just like taking the average between two items. You're trying to find the center. So the midpoint, we use a capital M for this, not a lowercase m. You might say, why? Why can't we use a lowercase m? Well, a lowercase m stands for the slope of a line, so we're not going to get that mixed up, and we'll use a capital M. So how do we find it? Well, you take the x values, take the difference, add them, and divide by 2. And then do the same for the y's, add them, and divide by 2. And that's how you find your midpoint. So let's use this for this next example. Plot and label the points A, B, and C. Okay, go ahead, pause the video, try to plot them by yourself. Alright, so A is 6, 7. 6, 7 right here. B is -6, -1. And C is 5, -5. 5, -5. Alright, what do we want to do next? Oh, we're going to want to draw this in. Sorry, missed that on my instructions. Go ahead, connect those points to create our triangle. So let me write that in. Connect. Yeah. Connect to create triangle ABC. Next, find the midpoint between A and B and label it D. Okay, how do we find the midpoint? Well, to find the midpoint, we're going to have to use this formula. Between A and B. What are the values in A and B? Well, here's A and that's B. So the midpoint, we're told to call it D. So D is going to equal 6 minus 6 divided by 2. And then we'll get 7, oops, wrong color. Let me change back. 7 plus the -1 divided by 2. So this becomes 0 divided by 2, which is 0. And then that is 6 divided by 2, which is 3. So 0, 3. Oh, right there. We're pretty close with our graph. And that is D. Next, draw a line segment between D and C. Okay, here's our line segment. Ooh, that looked horrible. Oh, try again. better. All right. Now, find the lengths of the sides of the triangle, D, B, C, and determine if it is isosceles, scalene, or equilateral. So we have our triangle, DBC, we're determining what kind of a triangle it is. Well, how do I know? Remember, isosceles means two of the sides are the same, scalene means none of them are the same, and equilateral means all are the same. How do I remember this? Well, for equilateral, equi means, or it's similar to the word equal. So that's it easy to remember. Equi, all sides are the same. Lateral is sides, so equal sides, equilat. Then, the next way to remember it is scalene. Imagine a dragon, and this is my attempt at drawing a dragon. Let's see, he's going to be breathing some fire. That looks like he has bad breath. Okay, what do we have on dragons usually? We have these things called scales, right? Now notice about the scales. Usually they are drawn where all sides are different. This side's a little shorter than that side, and then this side's a wee bit longer. That's how I remember what a scaling triangle looks like. None of the sides are the same. Yes, I have strange ways of memorizing things sometimes. And that leaves the only other option, if we have all three sides are the same, and this one says none are the same, that leaves the option of two are the same. So by default, isosceles is two are the same. That's how I remember it. Okay, well, we're trying to figure out what the sides are, but I don't know the lengths of any of these sides. How can I do this? Well, don't worry, we have the distance formula. We can determine the distance or the length between these points. Let's do that. So I'm going to find the distance between DB, then BC, and finally DC. Compare them and see what I get. So, BD. And it doesn't matter, you could rewrite that as DB if you wanted to. We'll take the difference between the x values. So B is -6 minus, and D value is 0 squared plus, then we color code these, 6, and then after that, we're going to go ahead and take the difference between the y values. So that would be -1 minus 3. Go ahead, pause the video and try to solve this by yourself. So -6 squared plus -4 squared is going to equal the square root of 36 plus 16, which is 52. And we have to answer as simple as possible, so let's see, what is in 52? Looks like 4 is in 52. So 52 is 4 times 13, which simplifies into 2 root 13. So that is the distance between these two guys. Now let's go ahead and find the distance between the other ones. So we want to find the distance between BC. And then the distance between DC. Okay, so between BC, let's see, comparing the B and C values, we have -6 minus, where's our C? 5. Square that, plus the y values, -1 and -5. Now notice, got to use the double negative there. Got to remember the parentheses because we have those negatives flying around. So that will be, let's see, -11 squared plus 4 squared, which will be square root of 121 plus 16. What is 121 plus 16? Let's see, type that into the calculator. We get 137. And can we simplify that? 137 actually ends up being a prime number. So we're done. That is as simple as it can be. Now lastly, DC. Okay, DC. Let's see. We're looking at these values and those values. So I'll just start with the C first. 5 minus 0 squared plus, and then let's do the Y values. Negative 5 minus 3. So notice the values from one of the points should always be first, and then the values from the other point would be second. So don't start switching who's first and second. 5 squared plus negative 8 squared, so that'll be 25. 25 plus 64, which is going to end up being, whack that into my calculator. 35 plus 64, 89. Anything in there? Well, 89 ends up being a prime number, so we're done. So now, let's see. Let's compare the sides of the triangle. It's kind of hard to compare a simplified radical with the other ones, so I'm going to back up to before I simplified it and compare these. Are any of these the same? No, these lengths are all different. So what kind of a triangle is this? This is a scaling triangle. Why? Because all sides have a different length. Period. Okay, so notice for this problem, you would not have ended on the square root 52. You should simplify it. We only looked back at the 52 for the comparison. All right, let's take a look at Objective 3, graph equations by plotting points. All right, let's go ahead and sketch the graphs of the following equations by using a table of values to find 5 points for each one. So what I'm going to do, I'm going to set this up with the same generic 5 points, and we'll compare the answers for each of them. So this is what a table of values kind of looks like. Pick an x value, figure out what y is going to be. So I'm going to use 2, 1, 0, negative 1, and negative 2. Use a mix of positives and negatives, because you never know, and then always throw in 0. Kind of a good rule of thumb of the numbers to pick. Okay, but for this one, I'm going to be dealing with a square root. So I'm actually going to pick perfect square roots for my x values. Now, when you're doing a table of values, you could pick any value you wanted to in the world to try plug in. I could pick 2,464. The problem is I don't really want to graph that number on my little graph below. So I pick numbers that are manageable to try and graph. So that's why we're going to stick for small numbers. Okay. So now let's go ahead and plug these values into our equation. Well, actually, this equation just says that y equals x. So whatever x is, y is also going to be that number. So just go ahead and mirror these down. Let's graph that. We have 2, 2 as the first point, and I'll graph this in blue. So 2, 2 is right there. And then what's the next point? 1, 1. 0, 0, negative 1, and then negative 2, negative 2. So this actually ends up being a line. Ooh, I'm trying. There we go. And I'll label my line with y equals x. And remember the arrowheads on either end of the line. Now let's look at the next equation. Absolute value of x. So this is saying y equals the absolute value of 2. Well, what is that? That's also just 2. Then y is the absolute value of 1, which also is just going to be, 1. Next one, y should be the absolute value of, we're inputting 0 for x, 0, which will just be 0. Next we have y is the absolute value of, and our new x value is -1. Input that. Well, the absolute value of -1 is +1. And lastly, inputting our new value for x, which is -2, we get 2. So the points here for this one are going to be 2, 2, 1, 1, 0, 0, -1, 1, and then -2, 2. So let's go ahead and plot those. I'll plot this in red. So 2, 2, stealing that one. 1, 1, stealing that one. 0, 0, stealing that. And then we go up to -1, 1. Oh, it bounces back up. And then we go to -2, 2. So this is what a generic absolute value equation looks like. It looks sort of like a V. Notice it doesn't bop down into the negative values for y. So y is absolute value of x. Now we'll take a look at the next one. Y is plus or minus the square root of x. Okay, so y equals plus or minus the square root of 4. That's my new x value. So that's going to be plus or minus 2. Then y is plus or minus square root of 1. So plus or minus 1. Okay, I'll just go ahead and fill this out. Oh, I ran into a problem. Can we take the square roots of a negative? No, that doesn't exist. We don't have any numbers for that. Not real number. Same thing happens for the -4. That's not any real number. So this equation actually does not work for negative values for y. So the only options we have here, actually, interestingly, we end up with 2 different points. We have 4 +2, then 4 -2. This one splits into 1 +1 and 1 -1. And this one, well, we don't really have positive and negative 0, so we just have 0, 0. So let's graph that. I'll choose green. So from the first one, we actually ended up with 2 points, 4, 2, and 4, -2. So let's graph that. 1, 2, 3, 4. So 4, 2, and then 4, -2. The next one also gave us 2 points, 1, 1, and 1, -1. 1, 1, and 1, -1. And lastly, we had the point 0, 0 at the origin, just like the others. So this one actually ends up giving me a sideways-looking parabola. How interesting. And there we go, using a table of values to sketch a graph. Now let's take a look at objective 4, identifying x and y intercepts. So I have a question. What is an intercept on the rectangular coordinate system? Well, we already kind of touched upon this earlier. An intercept is a value that crosses the axis. Let me draw it on the side. So for example, if I had my graph, let's say like that weird parabola I had earlier in green, my intercept would be the point right there, where it crosses the axis. How about the other one that I did? What did I have? I had the absolute value in red. So this one would also have the intercept right there at the origin. What if I had a line that went through like this? How many intercepts does that have? Well, it crosses the horizontal axis once, but then, it crosses the vertical axis once, but then it crosses the horizontal axis once. So this has a y-intercept and an x-intercept. And notice, for a point that is a y-intercept, what would the x value be? Well, the x value would be 0 for a y-intercept. It would always be 0 for a y-intercept. And then for x-intercepts, what would the y values be? Well, for an x-intercept, the y will always equal 0 for a y, or an x-intercept, sorry. Okay, so that's something we know for certain. For x-intercepts, y is always 0. For y-intercepts, x is always 0. That's going to be really helpful. Alright, now let's take a look at how to determine the x and the y-intercept, which we just went over. So writing this out, to find the x-intercept, set y equal to 0, and solve. Now this is for equations. So you would end up with your x-intercept value, comma, your y value of 0 as your coordinate point. Now to find the y-intercept, it's the exact opposite. Set x equal to 0 and solve. And then your answer would be written as, oh, actually let me change this one a teeny bit. You should write your answer as x-intercept, your x-intercept value, and 0. And then for your y-intercept, very similar. You would do y-intercept, 0, y-intercept. Notice, these are important ways to write your answer. You should write them as a coordinate point. They are a point, so make sure to write that out. Professors in the higher up classes want to make sure that that is done. Alright, for example 4, find the x and y-intercepts from the following. Be sure to answer in the correct format. So we're given a table for the first one, and then after the table, we're given an equation. Well, I know for the x-intercept, I'm looking for where y is 0. So in this column, where is 0 for y? Well, there's the 0 for y. So right here, this point is my x-intercept. So, oops, wrong pen. My x-intercept is 5, 0. Now go ahead and try find the y-intercept. Well, the y-intercept, we want x to be 0. So in this column, where is x 0? Right there. So my y-intercept is that point right there. Y-intercept 0, 5. All right, that was pretty good. So now let's try find the intercepts from an equation. So I'll set this up. Y-intercept. Actually, let me do the x first. Why not? Doesn't really matter. I just feel like doing it first. We don't know the x value, but we know the y value is going to be 0. And then for my y-intercept, I'll go ahead and set that up too. We don't know the y value, but we know the x value is 0. Okay. So 3y equals 4x plus 6. I'm going to write down my equation. And I am told to replace y with 0. So let's go ahead, take that out, replace it with 0. So that'll be 3 times 0 equals 4x plus 6. And now we want to solve for x. Well, 3 times 0 is 0. Okay, to solve for x, let's minus 6 from both sides. And we get negative 6 equals 4x. Solving for x by itself, divide both sides by 4. We can simplify that to negative 3 over 2 equals x. And that is my x value for my coordinate point. And there we go. I have my x-intercept. Okay, pause the video and take a moment to try to solve for your y-intercept. Okay, hopefully you tried to solve for it. So let's go ahead and copy down our same exact equation again, but this time we're replacing x with 0 and solving for y. Okay, well 4 times 0 goes to 0. So we're left with 3y equals 6. To solve for y, let's divide 3 from both sides. 6 divided by 3 is just 2, so y equals 2. I'll go ahead and plug that into my coordinate point, and there we go. My x and y intercepts, I've solved for both of them. Not bad. Okay, and that's it. So for graphing equations with a graphing utility, we don't actually do that objective in Math 103. We cover that in Math 135. So that is it for this section. Please email me if you have any questions.